is the how you create a buffer reader object, and I'll name it in for this program. And then to read from a buffer reader, if you want to read a string, you need to write the variable name dot read line, use the method dot read line, and it reads in a line from whatever the buffer reader is reading. And then to read an integer, you need to first read a line, and then you need to use the method parseInt from the integer class from Java in order to convert the string returned from .read line into a suitable int so that you can store it inside of a variable. And then these are similar methods for basically double and long. You use double.parse long, double.parse double, and long.parse long instead of integer.parseInt in order to read in longs and doubles. Are there any questions over this? Probably shouldn't. All right, now if you notice in the previous example, we're reading in a whole line. So if the line has like multiple numbers on it, it's kind of a problem because you can only read in one line at a time and then parse the whole line as an integer, double, or long. So in order to read in lines that have multiple tokens, multiple numbers, you need to use string tokenizer. So using the string tokenizer class, it is possible to read in ints, doubles, and longs on the same line. And the string tokenizer variable must be reinstantiated for every single line that you read in. And here's the example using buffer reader and string tokenizer. So in this program, we see in the input that it has multiple numbers on a line. And then we create a buffer reader object just like before. And then we read in one of the numbers using the previous method of just using in.readLine. But since the second line has multiple numbers on it, we need to use string tokenizer. So we create a string tokenizer object that reads and stores a line, which is this line. And we do this by doing string tokenizer token, the variable name, equals new string tokenizer in.readLine. And then in order to separate it into tokens, tokens are basically like numbers, except like data separated by spaces. So the string tokenizer will count this number 1 as a token because it's separated by a space. And then this 1.0 would be a separate token because it's separated by a space on both sides. And then this would also be a token because it's separated by a space. So token.next token just returns the next token on the line. So this very first call would return 1 because that's the next token. And then we would use integer.parseInt to parse the string return into a suitable int to be stored in the variable called b. And then we would do the same, basically using double.parseLong and long.parseLong for the other two numbers on the input. And if you want to read an additional line after doing all of this, you need to do token.newString tokenizer in.readLine because a string tokenizer object only stores one line every time you instantiate it. So you can instantiate it again to basically read the next line. Are there any questions? Okay. Yeah, I won't go over that. Okay, so basically that's the basics of reading in input using buffer reader and string tokenizer. All right, I guess I will go over the third problem now. So the third problem was called divisor sums 2. And I'll just read the problem statement in case you guys haven't read it. So let f of n denote the sum of divisors of an integer n. For example, f of 6 equals 1 plus 2 plus 3 plus 6 equals 12. your task is to calculate the sum f of 1 plus f of 2 all the way to f of n modulo 10 to the 9 plus 7. And the input is only an integer n. And then n is from 10 to the 12 to 1 to 10 to the 12. And for at least 60% of the test cases, n is from 1 to 10 to the 6. And basically, what this means for 60% of the test cases is all the way out to 10 to the 6 is that for 60% of them, you can do a linear time solution. But after that, you need to do something more efficient. And basically, my algorithm is a square root time algorithm. So square root of 10 to the 12 is 10 to the 6, which runs in time. All right, I'll just explain my solution right now. So consider the numbers a and b, where a times b equals a number n. And you know that all the divisors we're trying to count is going to come in pairs of a comma b, where they multiply to a number n. So we're trying to calculate all the different a plus b's. And basically, when we're counting the sums, we don't want to overcount and count it when count a plus b when a is less than b, and then count it again when b is a is greater than b. So in order to do that, we only consider the cases where a is less than or equal to b to attempt to not overcount. And basically, if we do this, we'll calculate a plus b whenever a is less than or equal to b. And so let's consider, we'll basically have a loop that loops through all the different possible a's, the lesser factor, and then we'll try to like use some mathematical formulas to to sum up all the divisors. So let's say we're considering a number a, where just like we're not considering a particular pair a times a b. We're just trying to count basically all the factor pairs such that a is less than or equal to b, and they multiply up to n. And then let me draw something real quick. So, oh, wow, okay. Okay, so basically n divided by a gives you the number of like numbers with a as a divisor when you're considering the question. And basically all the numbers that have factor a come in the form of a times 1, a times 2, a times 3, a times 4, all the way to a times n divided by a. N divided by a is actually floored. Okay, and then so we're considering a, and since a is less than or equal to b, we can do a times n divided by, okay, we'll just set this equal to, let's say, x. How do I erase on this? Okay, I'll just cross this out. Cool. So x minus a plus 1. This basically sums up all the a's when you in this sequence. All the way till a times a times n divided by a. Yeah, it sums all the way up to that. And here, this formula just sums all the a's on the left side. Because x minus a plus 1 gives the number of times you want to sum up the a, and then you just multiply by a. Now we want to sum up these numbers, but you can just realize that a plus 1 plus all the way to n over a is just this formula, x times x plus 1 divided by 2 minus a times a plus 1 divided by 2. This is the expression that gives a plus 1 all the way to n over a. Actually, it doesn't give this one because we don't want to overcount. So it's just a plus 1 plus a plus 2 plus all the way to n over a. And then if we do that, we should sum up all the divisors. I'm going to code out the solution now. Okay, so we have in n, we just read in the first number. And then for int, for a equals 1, it is, okay. I will explain the bounds for this for loop later. And then we will try to incorporate the first part of the solution, the first formula. So we'll have a variable long, a long variable answer just to keep track of the answer equals 0 right now. And then, so the first part is equal to, let's say, it's a times, oh yeah, let's also store n divided by, this has to be a long too, sorry. So long x equals n divided by a inside of a variable just for convenience. So this is the x we were referring to. And then we do x minus a plus 1, which is the first sum we calculated. And then the second sum was x times x plus 1 divided by 2 minus a times a plus 1 divided by 2. And then we do answer equals answer plus first plus second. Okay, but the thing is, you need to remember that the question asks you to find this in terms of modulo 10 to the 9 plus 7. So then you have to do, you have to basically do modulo arithmetic here. And here, I'll just adjust the code in terms of mod. Basically, you just mod everything.
What is the purpose of the first plus mod?
Which one?
Yeah, the x minus a plus 1 plus mod.
X minus a plus 1. Actually, like, yeah, you don't really need this. Generally, it's like you can add in like mods if you're adding and subtracting, and you don't have to worry about like how that'll affect your solution. So whenever you subtract, you can like always just add in a mod so that like you want the resulting modded answer to be positive, but if you subtract, it might be negative, and percent mod in Java doesn't like convert it back to positive. So you have to add mod first to make it positive and then mod it. So in this case, you don't really need the mod, but in general, a good tip is you just to, like whenever you subtract, just stick in the plus mod just to compensate for the subtraction.
Okay.
Yeah. And then this, yeah, I did this based on instinct too. I just saw a subtract sign and then added a mod. And then here you can just mod again. And then this is just the answer. Yeah. Yeah. Does anyone have any questions about the solution? I don't know if I explained it very clearly. Okay, so since no one has the solution, I'll just hand it over to Victor, I guess.
Okay, so that's basically the end of our meeting. I did plan to have this hashing lesson in case there was time, but I think there's no time left. There's like 16 minutes.
Victor.
Yeah.
It's possible to create a survey to see so the kids can answer maybe even anonymously how much do they gain, how many of them actually tried the program, how much are they get something as far as their comments are concerned. So I liked both of them, Daniel and Andrew. They did a really good job, but I know that you guys are upper level kind of kids. You've done all of this and I understand what they're doing, but I want to see if you can get some feedback from the kids also, so then they continue with us.
Okay, I will make a poll that like right now to see if this like on a scale like 1 to 10, how much you understood the solutions.
Yeah, or just saying that what else would they like to see. Try to get a general comment up from kids every day. Okay. But thank you for doing this. I mean, most schools are not even able to do this much at this point. So I totally appreciate it. And I appreciate everyone who is here. I'm seeing Yifan. I haven't heard from him for a long time. And a lot of kids, I'm just looking. Alex is here, Ryan. So it's good to see you all. And hopefully, okay, I didn't put my camera on this time on purpose, but that's okay. But you're doing a great job. Okay, so continue. Thank you.